Okay, so let's start the introduction to statistics using R. Statistics. So, what is the definition of statistics? It's a science of collection, presentation, analysis, and reasonable interpretation of data. Statistics presents a rigorous scientific method for gaining insights into data. For example, if you want to measure the weight of 100 patients in a study with so many measurements, simply looking at the data fails to provide an informative account. So basically, even if you measure the 100 patients weight, it won't give you any information though you have the data. But however, statistics can give an instant overall picture of the data based on graphical presentation or numerical summarization, irrespective of the number of data points. Besides data summarization, another important task of the statistics is to make inference and predict relations of variables. So what statistics does for the business analytics is it provides the algorithmic or the mathematical support to handle the large data points, because we know in the business analytics, let's say you are doing an exercise on the fraud prediction, then you have lakhs of records, and without statistics you cannot move ahead by the analysis of the data. You need to know what are the measures of central tendency, what is mean median mode, how the data has been varied by looking at the graphical representation, how many outliers are there. So all those things comes from the statistics. That's from the first account, that it can explain the data. Second account is it can help you in summarization of the data, and it can also help you in the prediction of the relations of the variable. So when we go towards a prediction like regression and things, then regression also is a statistical technique. Then we would be using a lot of things in intermediate like correlation, like covariance. So all those predictive relations are defined or been explained by statistics. So the role of statistics is very crucial to business analytics. I'm not saying that a business analytics manager needs to be a statistician to say, but he should have a fair enough idea of what is the relevant measure to analyze the data, and how do we interpret the result. I think these two things are very crucial. What is happening inside, I would say don't focus too much on the formulas, but the point is which technique and when the technique needs to be applied, and how do you interpret the results of the technique is very crucial for a business analytics manager. Okay, so again, going deeper into statistics, I was telling you what are the important. So this I picked up an example from a genome sequence. So can we tell anything by looking at the sequence? With the human intervention, no. But we know that if we use statistics, we can do something good, or we can extract something significant out from this sequence. So the question that arises in the mind is, what sort of statistics should be used to describe the sequence? Can we determine what sort of organism the sequence come from based on the sequence content? Do the parameters describing the sequence differ from those describing bulk DNA in that organism? What sort of sequence this might be, protein coding, or it can be a transposable element. So the basic idea is, by looking at the complex data, this is also a complex data, and then from a business analytics manager standpoint, I should know that what is the relevant statistic technique, then that I can feed in here and get the relevant insights out from the data. Okay, so why we need statistics? Because everything varies. So whatever you see today is going to be a different statistic around it. So if you make an assumption that all the kids less than 14 years of age, their daily expenditure is 100 rupees, but this statistic will will change drastically after 2 years. So everything is so variable, then you need to catch up with this statistic, and you need statistics for that. So if you measure the same thing twice, you will get two different answers. That's where you need to take a call, and you need to know statistics. Heterogeneity is universal, spatial or temporal, but it's universal. We need to distinguish between variation that is scientifically interesting and variation that just reflects the background. So the idea is, the observations are so heterogeneous in the nature, then we to justify that or to explain that we need statistics. Second point is significance. So while we go deeper into statistics, we'll see there's something called significance, and there's a point upper band of significance, lower band of significance. We read all that. We'll get into all that, but the point is a result is unlikely to have occurred by chance. Result is unlikely to have occurred by chance if the null hypothesis was true, or the null hypothesis says that nothing is happening and the alternative says something is happening. So null hypothesis has to be falsible hypothesis. So let's not get into the hypothesis, but there's something. So there is no so let me explain it that way. So there's no fuzzy, there's no boolean logic. So this is true and this is false. There would always be a significance level. I would say it till 0.9% it can be, or till 90% this can be true, or till 95% this can be true. So that significance level has been defined using statistics. Okay, why R has been used in collaboration when it comes to statistics. So R first appeared in 1996 when the statistics professor Robert Gentleman left and Roz Elaka released the code as a free software package. So R initially started as S programming. That was the idea was to help the statisticians. It was not a fully business analytics sort of programming, but the evolution of the R, the way it has been growing, and it's an open source, so everybody can make packages for it. So nowadays with the business analytics also, R has some, though it has the initial statistical capability, but nowadays they have a lot of data mining or a lot of data interpretation, manipulation, and predictive analytics capabilities as well. So the idea was why R was linked to the statistic, because the core of the R was statistics only. Comparison, I've picked up this from one of the literature. So it gives not a very detailing, but it gives a quick advantages, disadvantages, availability, and who are the typical users as is. But so typical users, I would say it's not limited to this table. This is just an indicative table. So let's say with the so there are two open source. So let's start with the open source. So R and Python. So row number 3 is a Python, and first row is the R. They two are the open source. Anybody can go on the web, can download and can start using it. While others like MATLAB, Excel, SAS, Stata, and SPSS, they are not open source and they are very expensive too. So that's the first thing to start with. And typical so advantages with the R are, we have a library support, we have visualization for it. Disadvantages, since R doesn't have a very good UI, and the person needs to be very well equipped with the coding or very well equipped with the idea of packages, how to use it. So there might be a steep learning curve, but I don't see it as a very big disadvantage. People who are exposed to the programming environment, I think that's it's going to be a smooth learning process for them. So again, MATLAB is expensive. Similarly with the SAS, it's very expensive, and SPSS. So if we compare disadvantages amongst the SAS, SPSS, and MATLAB, they three are expensive. Excel is not that expensive, but it cannot handle a very large set of data. So if you want to do anything quick, data manipulation, interpretation, but with the small data, Excel is a good tool. But the point is, in the real life, the data cannot be that small. So we need to go for a tool that can handle the large data sets as well. So this was a quick table. So the key takeaways, if you want to use open source, then it's R and Python, but the learning curve is pretty steep. But if you want to do a quick analysis, then it's an Excel. If you want to go for a professional analysis, and if the company you're working for has very deep pockets, then we can go for SPSS, SAS, or MATLAB also.